Now, suppose the Earth is a perfect oblate sphere, or is a perfect sphere with radius 6370 kilometers. Good. The person weighs exactly 600 newtons. Some other stars and this place weighs 600 newtons at the North Pole. How much would the person weigh at the equator? Now, don't forget that at the very North Pole, the force of gravity is equals to weight at the very North Pole. Why? Because there is no distance between the body standing at the North Pole and the North Pole itself. So, what would the person, if you look at the person weighs 600 Newton, don't forget the weight is 600 Newton at the North Pole, which is sitting as the force of gravity. That's what it is. So, 600 Newton is equals to mass times gravitational, force. So, what's gravity? Gravity is 9.8 meter per second square. So, you're going to do that. The 600 Newton is mass. You're going to get the mass of the body first. 9.8. The Bible says about 9.8. Both have at 9.8. What do we have? The mass is, let's quickly use our calculator. It's going to help us out here. So let's see. The mass would be 600 Newton divided by 9.8. So the mass would be 61.2. That's 61.2, that's a kilogram. Don't forget, we have different systems. We have the CGS system, which is centimeter, gram, and second. We have the MKS system, which is the meter, kilogram, and seconds. So everything we're working on right now is based on the system: mass, meter, kilogram, and seconds. So the mass is in kilograms. It's 1.2 kg. That's the mass of the person standing at the North Pole. So that's the mass of the person. So now look at, so if the person weighs exactly 600 Newton at the North Pole, yes, we know that. How much would the person weigh at the equator? Simple. How much would the person weigh at the equator? Now look at this formula. The force of gravity minus weight is equal to this. Mass times this, angular that is velocity raised by 2 times radius. We know what the radius is. Radius is 6,370 kilometers. That is well known. So quickly, let me take up this place. Let me bring it down here. Let's make some room. Let me bring it down to this place. I'm trying to get what the person will weigh at the equator. The person weighs 600 Newton at the pole. So we're trying to get what the person will weigh at the very equator. So now let's see what the person will weigh at the equator. Now look at the force of gravity minus weight equals this. Now, the radius stated, the radius is simply the distance. 637 kilometer, that's the radius, we know that. Now, what's going to be the angular speed? The angular velocity is what we're going to get right now. Angular velocity is 2 pi over period. Now, don't forget, when it comes to the Earth completes